Today, we want to consider sets. Our example will be based on intersection and union of sets. For those of you who are first timers here, kindly subscribe to the channel, share the videos to other friends, and the video may be helpful too. So here we want to say that we say the sets A, B, and C are subsets of the universal set U. So the universal set is a set of integers, but the integers, we are given this constraint, the integers x, and the value of x are constrained between 1 to 20, less than or equals to, that is from 1. If you see, suppose it's less than 1 is less than x, that means x will take the value greater than 1. But since they say it's less than or equals to, that is, could be equals to 1, 1 could be equals to x or could be less than x, meaning that x could be 1 or greater than 1, meaning that x start from 1 to values greater than 1, like 2, 3, 4, 5. So far it is integer within that range. And at the upper end, so we have x is less than or equals to 20. That is, x could be equals to 20 or less than 20. That is, x, the highest value of x here is 20, or something less than 20, like 19, 18, and so on. Invariably, we want to list out 1 to 20 as the element of universal set, and that's what we have to do in A. So list out the elements of the set. So ABC. So, but first of all, it's good that we list out the elements of the universal set too, which is 1, 2, 3, 4, and so on, 19 up to 20. It is good that you write this special bracket for sets. It is compulsory. Don't write this. This is not acceptable in external examinations. So the other elements like A. The elements of the set A, since we are given that A is multiples of 5, multiples of 5 includes those numbers that are divisible by 5, and the list of them is 5, 10, 15, 20. So you can list beyond the universal set. Everything you will list, since A, B, and C are subsets of this universal set, all the elements must be limited to the elements in the universal set. So we have B. For B, factors of 20. Factors of 20. Factors of 20s are numbers that can divide 20 directly without remainder. That is, numbers that 20 is divisible by. For example, 20 is divisible by 1, 20 is divisible by 2. So because 20 divided by 2 is 10, we give whole number. So 3 is not, 4. Yes, 4 can go in 20 directly. 5, 6 cannot go, 7 cannot go, 8, 9, no, 10. 10 can go. 10 is factor. After 10, do we have any other number? No, so it's only 20. 20 can go in itself. So we have this. Then for C. For C, what do we have in C? Prime numbers within the range of universal set. Prime numbers are numbers not divisible by any other number except 1 and itself. And every prime number has two distinct factors, which is 1 and itself. And that itself must not be 1 again. That is why we will disqualify 1. 1 will not be a prime number. Because we say 1 is a prime number, 1 and itself is still 1. They are not distinct. So we start from 2, 3, 5, 7, 9 is not there, 11, 13, 17, 19. Okay, so from here we want to use these elements that we have here to answer the following questions, which is A intersection B intersection C. What do we mean by intersection? What is common? Intersection is what is common between two or more sets. If I say A intersection B intersection C, what element is common to A, to B, and to C at the same time? So, if we check carefully, where is there any element that is common to the three of them? Let's check. So for B, I, A intersection B intersection C. Let's check what is common. Of course, I have observed that we have 5 here, we have 5 here, we equally have 5 here. Is there any other number? We would have had 10, but 10 is here and here, not here, so it's not among. So we have only 5 as the element there. And for II, we are to find the number of A union B. It is important for us to know that if it is number, it is this n, but if it is intersection, it is this kind of n. Without, can you see the difference? If it is union, so don't write union as letter U, write it this way. So to find the number of A union B, first find A union B self, the element of A union B. A union B, union means you are adding them together. You are adding the results together. Add the results together. Add the results together for A and B. And we have A here, we have B here. Add the two results together. But some elements like 5 appear here and also here. So you just write it once. 10 appears here and here. Write it once. So we have anything you can see in either A or B or both. That is A union B. So we can see 1, we can see 2, we can see 4, 5 can be seen, 10, 15, 20. So that is A union B. Hence, what we are required of is number of A union B, which entails counting how many elements are in the set A union B. So in the set A union B, 1, 2, 3, 4, 5, 6, 7. There are 7 elements. That shows number of A union B is 7. Then the last aspect on this example is we have to find A union B prime. A union B prime. To do this, that means we first find the value inside the parentheses, which is A union B, which we already have here. So you don't need to refine it. Then to now find complement. Complement of anything means the values inside the universal set that are not present in that set itself. If I want to find complement of A complement, what are the elements inside the universal that are not present in A itself? They are the complement of A. So complement of A union B here are elements present in the universal set but not present in A union B. If you check A union B, what are the elements in the universal set that are not in this A union B? So if you check in the universal set, we have 1 here, we have 2 here, 3 is not, and 3 is in the universal set. So we have 3, 4 is there, 5 is there, 6 is not here, 6, 7, 8, 9, 10 is there, 11 is not here, 12 is not here, 13 is not there. 14 not there. 15 is there. 16 is not there. 17 is not there. 18 is not there. 19. So, and this is the results that we have. We move on to set 2, and that would have to do with shading of Venn diagrams.